Welcome back. In this video, we're going to talk about notation, just different ways to write inequalities. So specifically interval notation and set notation. This will be connected to some kind of inequality solves. We're going to be doing a couple quadratic inequalities at the end here, but the focus is on the notation. So the big thing is off the top, both these notations are completely fine. Unless a question asks specifically for one, you can do either one you'd like. They do have strengths and weaknesses, which we'll kind of get into as we attack this one. So this first I do says we want x less than -2, strictly less than -2, or x greater than or equal to 3 in interval and set notation. So first of all, what are the two? So interval notation, let's start with interval notation. This uses brackets. So you can kind of see the reminder. It's going to use brackets, two different types of brackets, round brackets for non-included boundaries and square brackets for included boundaries. Infinity, you'll never reach it, just an idea, not a number. That's a whole other topic. But infinity will always get the round bracket. IB, if you prefer the IB brackets, IB instead of round brackets, they're going to use kind of outward facing square brackets, which is also fine. So interval notation, all you're going to do is basically use those brackets. So for this first kind of piece, x less than -2, we're going to say, okay, so we're talking about x. That's a big thing. Don't forget that x is an element of. But x is an element of everything less than -2. So that's basically saying anything up from negative infinity all the way up to -2. Now, because it's a strict inequality, I am going to keep a round bracket on that. So that right there, get rid of all that, that is my first bit. But I know I also want this all or x is greater than or equal to 3. So the way we write or is with the union sign. That means or. So I'll kind of highlight that. So or is that union sign. And the final piece is x is greater than or equal to 3. So again, all we do with the intervals, we're going to say, so this interval starts at 3, and it's going to go all the way up to infinity. Again, we can't include infinity. We do want to include an inclusive inequality on the 3. So 3 gets a square bracket, and that is interval notation. So notice all those pieces are necessary for the final product. I'll just kind of highlight it again. So interval notation, when's it good? Well, it's really good when you have continuous values because it's really quick and easy to write. So continuous real numbers, interval notation is probably the one to go with. That's the one you'll see by far the most from me. Let's do this one in set notation though. It's a little clunkier, but it's fine. In set notation, what we're going to say is, well, we're going to start with x is an element. What type of number can x be? So here it's a real number. So x ER. We're going to put this in set brackets, and then we're going to add a vertical line which is such that. So what we're saying here is, okay, x is a real number such that, and then what are the rules in x? So x is less than -2, or x is greater than or equal to 3. Now, remember that was given to me, right? So like very rarely would a question actually be posed like this, like here's the inequality, write a different way. We would probably do a solve like we're going to see in I do 2 and you do 2. But that is set notation. So notice you do need all those pieces, right? You can't just write the inequality. You have to be interval or set notation, right? So it's longer, it's a little clunky, but it ultimately does the work. Notice that I cannot, and this is when we see a lot, students will see this -2 and 3, and they're going to try to write it all together. So they're going to say x is greater than or equal to 3, less than or equal to -2. You can't do that because when you're writing as 1, you have an implied and statement. And just check that. See if you can find a number that works for that inequality. So you want a number that's at least 3, but also less than -2. And you'll see that's not possible, right? So you do need the or. You can't just write it as that one kind of continuous inequality. That's a really common mistake. So do not do that. Okay. I got one for you here. So I'm just going to pull it up. So you do 1. So again, pretty simple one. I'm going to give you the inequality. I just want you to write it both ways. So x is at least -1 and less than 4. So write that in interval notation, set notation. Pause the video and we'll come back for the answer. Okay, there you go. Quick, right? So here, hopefully you can see integral notation is starting, hopefully to take the lead a little bit. It's a continuous real number. So x is between -1 included, 4 not included, end of the question. That's it. Set notation on the side there, again, is also fine. Be able to read it, but again, I think integral notation does kind of take the cake there. There are a couple of times where it won't, which we'll talk about at the end here, but yeah. So next question is, what if we don't know the inequality? So this one just says, hey, solve x minus 1 times x plus 3 is greater than 0. Now this is a quadratic inequality, so I don't want to get too far down that road, but we will solve one here. Remember, the basic idea on a question like this is going to be, we want to find the boundaries. So the boundaries, I'll just kind of write this in green here. The boundaries is going to be, so when is this thing equal to 0? And then we can pick which side of the line we want. So this is going to be equal to 0 when x is 1 or x is -3. So what this essentially does is our number line of all possible solutions is split into 3 pieces. Everything before -3, everything between -3 and 1, and everything after 1. Now we can test points, right? So the way we would test points is we would pick a value for each of those. So for example, we could say, hey, what happens if x is -10? Now I don't actually care about the numbers. I'm just checking it inside of this. So I'm going to say, well, so -10 minus 1 would be negative. -10 plus 3 would be negative. Negative times negative is positive. So that would be a positive number. What if x is between these two? So that would be, hey, what if x is 0 is a nice number to pick there. So 0 minus 1 is negative. 0 plus 3 is positive. And negative times a positive is a negative. And then finally, what if x is bigger than 1? For example, 10. So if x is 10, 10 minus 1 is positive. 10 plus 3 is positive, 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 makes a positive. That is using test points. That's fine. You can do that. It is a little longer. What I would do, especially with one like this, is just not do that. So with my number line, I'm just going to use what I know about quadratics. So I know this thing opens up because it's a positive a value. So it's going to look like this. And then on that sketch, I can see, well, it's positive on the outsides, negative on the inside. And I didn't fill this one in. So you can see those match. So either way, we have that it's positive because we want to know when is it positive. So it's going to be positive on the edges, right? So before -3, after 1. So writing this in interval set notation, really run out of room here. So in interval notation, I'm going to say, so x is an element of everything up to -3. Now notice it's a non-inclusive inequality. So I'm not including -3 or everything greater than 1. Again, exclusive inequality. So that's interval notation. Set notation, very similar, is going to say, okay, x is a real number such that the rules x is going to follow is it's going to be less than -3 or bigger than 1. So notice, again, I do have to write those 2 pieces. So either one of those is fine. Be able to do both, be able to read both, but they're both fine. Last question, one for you to try here, is going to be solve x squared minus 4x is less than 0. So pause the video, try that one, and we'll come back for it. Okay, welcome back. There is the solution. So I'm not doing test points here. You can. I just did a quick sketch. So I see the boundaries are at 0 and 4, and I want to be less than 0. So I want to be negative. So I want to be negative in there. Right, so that is it. Whereas up here I wanted the positive, down here I want the negative. So that's it, interval and set notation. I said at the end I would kind of look back for interval versus set. If it's an open domain, so if there's no restrictions, in interval notation, you would say x can be anything from -infinity to +infinity. That feels a little clunky. In set notation, it's a little better because you could just say, hey, x is an element of the reals. That's a little nicer. The other ones you'll see set notation sometimes nice if you're just missing one number, right? So if x can't be 2, um, you could just say, so this is all real. Let's say x can't be 2. In set notation, you could just say, hey, x is an element of the reals such that my rule is x can't be 2. In interval notation, this is where it does get clunky. You're going to say x can go up to 2 or it can go above 2. Right, so those are two kind of specific situations where set notation might be a little bit better. But besides that, assuming we have continuous real numbers, I'm probably going interval notation. And that's the video. Thanks for watching.